We're going to now move on to the next presentation that looks at a use case for AI that is not really short of data, as some of these papers have mentioned. We're going to look at newspaper content and how this is being analyzed in the project called Impresso. And to tell us all about it is Ehrmann from Digital Humanities Laboratory in Lausanne, in Switzerland. Please.
Hello, and welcome to the presentation of the project Impresso, Media Monitoring of the Past, at the occasion of the Digital Memory Seminar of the National Library of Estonia. I'm Ehrmann, and I work as a researcher at the EPFL Lab in Switzerland. I will give you a very brief overview of this interdisciplinary project on historical newspaper mining. I'm the only person talking here, but it goes without saying that the whole Impresso team and partners are behind this work. So this project focuses on historical newspapers. It is long that we do not see any more newspaper sellers running towards us like this, but we are all very familiar with newspapers. They are published in centuries on a regular basis, and they act a bit as mirrors of past societies. They record wars and minor events, they report on international, national, and local matters, and document the day-to-day life. In a word, they keep track of the great and the small history, and they hold a very diverse, dense, and continuous information. Historians are well aware of the value of these sources, and they use them since long to work on various historical questions in, for example, intellectual, economic, cultural, or diplomatic history. The interest of historians is all the more important since the traditional barriers to the use of historical newspapers, that is to say, difficult access and tedious exploration, have started to fall. If 10 years ago, one needed to turn a lot of pages and to read countless articles to find what she or he was looking for, nowadays, many libraries are offering online portals where it is possible to visualize facsimile and to search the text extracted by means of OCR, search often completed with metadata facets. So this represents a huge step ahead in terms of preservation and access to documents. However, keyword search is not always satisfying, and there are issues such as too many hits, irrelevant hits, or false negatives caused by bad OCR. What is more, and somehow paradoxically, if data is accessible now, it is somehow still too big to be explored, and researchers get lost in this wealth of text. So if we ask historians what they would like to do, their requests are, for example, the following. They would like that we help them, for example, to expand their query based on common OCR mistake and spelling variants. So for example, if someone will look for the word Regierung, meaning government in English, it will be good if an automatic system could suggest morphological variants of this word, as well as words having similar meaning. In this case, we could have the support of automatic lexical processing. Another request, which comes often, is help me find the frequency of a word, which is quite classic as a request, but I would like this in articles of a certain type or certain thematic. And this echo as well the wish of being able to distinguish between real occurrences from false positive coming from, for example, stock market or advertisement. In this case, we will need to segment the pages of newspaper as well as to classify them. And for this, we could rely on segmentation techniques from computer vision, as well as on classification techniques from natural language processing. Another request, very classical, help me to find the name a person in the article. For example, I want to find Jean Monnet, and I want the right one. I don't want its homonym. And once I find this person, I would like to know with whom this person was mentioned often in the corpus. And perhaps more specifically to historical newspapers, people would like to distinguish between articles mentioning the person as an author of the article versus as the main subject of this article. And in this case, we could rely on name-entity processing techniques from natural language processing. And there are many other requests which people would like to fulfill, like such as discovering similar items that someone might be interested in, appreciating the high-level thematic of a corpus or subpart of it, or being able to interact with the data and to build one's own collection. So we can conclude that there is a need for much more than keyword search, and that we should try to ask ourselves how to enable semantic indexing and exploration of large collection of historic newspapers. So this is what we try to do in the project Impresso, a 3-year project which was funded by the Swiss National Science Foundation and which just finished a few months ago. This project gathered 3 main partners, namely the EPFLDH Lab in Lausanne, the Institute of Computational Linguistics of the University of Zurich, as well as the Center for Contemporary and Digital History from Luxembourg University. We also received the support of associated partners who provided us with data or helped us with historical research and co-design. To achieve this objective of newspaper data mining, the Impresso team was composed of people with various backgrounds, such as people coming from NLP or digital humanities, people who are specialists of design and web development, and naturally also historians. We also team up with a historical advisor and several associated with historians. So this was our team, and our plan to do this was the following. So very briefly, first, we collect sources from archives of different countries, mostly Switzerland and Luxembourg, in French, German, and Luxembourgish. Once we have the sources, we prepare them for processing, and we design, we adapt, and we apply a series of natural language processing techniques in order to extract the information contained in these sources. Here, what is at stake is to adapt natural language processing tools on historical and noisy data. And once we have extracted information, the objective is to make it accessible, that is to say, to develop an interface which allows to explore and visualize the source and the semantic enrichments. Finally, once the data is semantically indexed and it is possible to explore it, comes the step of really historical research. Overall, the target user of our interface is mainly historians, and from a historical perspective, the objective was really to improve content discovery beyond keyword search and to enable source criticism based on natural language processing enrichments and interactive data visualization. So to sum up, the main objective of the project were to improve text mining tools for historical text, to enrich historical newspaper with automatically generated data, and to integrate such a data into historical research workflows by means of a newly developed user interface. To achieve these objectives, we have been facing 5 main challenges that I would like to very briefly outline here. The first one is a very well-known one and relates to digitized newspaper silos with 2 main issues, coverage and accessibility. Regarding coverage, a survey showed that libraries have digitized approximately 10% of their newspaper holding. Therefore, the digital landscape of newspaper is very partial and fragmented, and this needs to be kept in mind. Then, even if newspapers are digitized, doesn't mean that they are accessible. And here is a profile of digitized newspaper in Europe, and here is the one of those available in open access. We are thus facing quite a complex and opaque landscape of media silos, and it's not easy to obtain the sources to work with. Our answer to this challenge was to devise and to implement institutional and technical frameworks which allow access to source for research purposes while respecting different copyright policies. So with collection partially digitized and not always accessible, we face somehow a tension between homogeneity and coverage, which is not always compatible with the research practice of scholars and historians in particular. On the one hand, if someone wants a very perfect and homogeneous data set, it will be nice, but it will be very, very small. And looking for coverage, we'll go towards something like what exists today as Google Book, very big, but very heterogeneous. So both are not really satisfying for research purposes. And somehow the current situation with respect to digitized newspaper is in between, and with more digitization going ahead, we perhaps go towards a better situation. So this was the first challenge. The second challenge relates to data, physical acquisition, and pre-processing, aspects which are, it's 2 aspects which are often overlooked. So what is the data which arrive to us in such a project? Well, different things. We first have the output of the OCR, which comes in different formats, Mezzalto, proprietary formats such as Olive, PDF. Then we have images, which come also in different formats. And finally, we have some metadata, again, in different formats. So the first thing we have to do is to transform this digital archive into processable data in order to be able to process it at scale and in the same manner. So what we do is actually to normalize, meaning that we bring everything to a common representation. And what we have to keep in mind is that each time we normalize, there is a risk of losing data. And so what happened really concretely during this process, we had many surprises and discovered that digitized sources are really, to put it frankly, quite messy. Regarding OCR data, we encountered the problem of empty folders, corrupted archive, and many inconsistencies. These problems certainly have their origins in previous steps, and for this, we try to collect information. Similar problem occurs with images, with box coordinates, for example, which are rarely correct, as well as metadata, which is often incomplete and non-normalized information. So overall, before processing text, there are a lot of hidden steps which really lay the ground for all the rest, and caring about quality in a big data context is not easy. Our answer to this challenge was to devise what we call canonical data formats and importers, appropriate not for data preservation and archiving, but for large-scale processing. And we also try to trace as much as we can all data processing steps and meta-knowledge. When the data is ready, we are happy to start processing it, but then comes the problem of the third challenge, mainly noisy and historical text. Here we can see the frequency of the term gazelle in a Swiss newspapers, and we can notice an increase of the mention of this animal in the middle of the 19th century. Obviously, Switzerland did not have a lot of gazelle, but a lot of gazettes, such as the one of Lausanne. Our answer to the challenge of bad OCR was diverse. First, we tried to improve the OCR quality by computing new models, especially for black letters, which demonstrated the possibility to improve the quality by a large margin. Actually, these models motivated the archive holder to redigitize the collection in order to have scans of better quality. Second, since our primary objective was not to entirely redo the OCR, a second strategy to deal with bad OCR was to assess its quality at the article level in order to allow users to estimate the completeness of the keyword search results. The measure is computed by considering content words only and is meant to be easily grasped by non-technicians. So despite all these challenges, we devised, adapted, and applied a range of text and image processing tools on our collection. First, we apply some lexical processing in order to identify the language, normalize historical spelling, do some lemmatization, and we also compute word embeddings. We also compute the quality of the OCR for each article. Then going from the lexical to the conceptual level, we apply topic modeling in order to automatically extract the topics of each item of the collection. We also apply non-entity processing, naming mainly recognition, classification, and linking of person, location, and organizations. We compute text reuse in order to identify similar passages as well as image similarity in order to enable visual search. We also implemented the first prototype of a recommender system as well as key phrase extraction. These techniques are very briefly mentioned here. For more details, you can visit the Impresso project YouTube channel. And obviously, these techniques are not perfect, and we constantly work on improving them via, for example, the organization of shared tasks. So that was how we dealt somehow with noisy and historical text, and we apply natural language processing tools on the data. And the fourth challenge actually related to the question of, once we have this information, how to best accommodate this text analysis research tools and information and their usage by humanities scholars. In other words, how could we develop a search application which is helpful for historians and in line with their research practice and needs? To answer such a challenge, our answer to this challenge was co-design and fast prototyping. The principle here was really to have continuous exchange between all members of the team and the consortium in order to learn from each other, experiment, evaluate, and this was implemented via regular workshops, interaction with associated researchers, Impresso community call, etc., etc. So overall, an interface is not a static thing. It is really the temporary result of a pretty long series of interaction between people with different backgrounds that you can see represented on this picture. Here, there are historians, archivists, librarians, NLP specialists, engineers, designers, and developers. And we gathered together with the ambition to design an interface which could make research activity faster and easier. So how could we embrace all these different visions? Well, by really implementing co-design. So very briefly, how did we do? We had two starting points mainly. The first one was historical research scenario made by historians in order to sketch and operationalize the research question. And the second one was wireframes, as you see here, in order to sketch the first component of the interface and the first functionality. So we started by identifying already existing component or kind of easy component, how to plot a timeline, how to visualize a facsimile, and then we look for the more invisible flaws or problems that make the research of historians longer or more difficult. We collected feedback along several workshops. So here on the left, you see the first wireframe that was designed during the project, which was somehow the ground zero on which we discussed and imagined new features, such as having marginalia along the page of a newspaper in order to get a distance reading of this page. And on the right, we asked workshop participants to fill the classical table of strengths and weaknesses with a list of the visual components mentioned in the wireframe. So we gathered this feedback via a user workshop during which usual scenario emerged, such as how to search for articles and read their content, but also less usual scenario, less common one, such as how do I know if my search is complete or did I miss something? Then we put together all these ideas in prototype and we evaluated, developed, iterated, and developed slowly the application in this manner. So in this sense, we can say that each component of the interface has a whole story to tell and has seen many transitions and is a result of hours of discussions. Let's take one example. These are a couple of transitions from the initial idea of comparing items in a collection on the left. Then in the center, you see the same idea after preliminary exchange with historians, and this result was not satisfactory. And then finally, on the right, the latest concept, which eventually led to the current much complex version of the inspect and compare component in the interface. And this is probably not the last version of the component. So the main advantage of this collaborative design method is that of transparency and inclusion. And we can say that almost everything in the interface is a result of a continuous exchange and dialogue between different disciplines. Finally, if we have new ways to engage with contents, these also mean that we have new ways of using it. And the main question here is how historians could work with algorithmically generated, changing, and certainly imperfect data. Answer to this challenge correspond to two guiding principles that we apply when developing the search application, that is to say transparency and generosity. Transparency corresponds to the question of what am I looking at? And the objective is really to give all information to help assess critically the sources and their enrichment. This corresponds to the issue of digital source criticism. And generosity corresponds to the question of what can I do with all this? And here the objective is to guide and support new research workflows based, for example, on discovery functionalities. Very briefly, how transparency matters, really the idea is to keep in mind that a very beautiful interface doesn't mean that everything is perfect. And if something is not perfect, doesn't mean that it's completely useless. And we need to make this information really visible in the interface because we inherit, we introduce, and we propagate bias and variance in our corpus. And the question is really how to communicate it to historians, to the users, and what a user really needs to know in order to be able to deal with this. So we implemented transparency in different ways. Briefly sketched here, we try to give information about missing data. We also give information about the OCR quality, and we provide quite extensive documentation via FAQ and information buttons, which give information about underlying processes which generated the data. So these were the the 5 challenges, and I will now give you a very brief demonstration of the system. So here is the welcome page of the interface. In the central part, you can see that you have access to what we call impresso challenges, a series of PDF where we offer a guided tour of the interface with some exercise to understand the main functionalities. On the left-hand side, there are some statistics about the corpus and their notation. I would like to do a brief demonstration using the keyword Ehrmann, which is the name of a battle which happened in 1944 at the end of the Second World War. With the auto-suggest, I can look in article contents, titles, but also I have access to entities which have been recognized. For now, I simply look for the keyword Ehrmann, and I have a result search kit composed of approximately 4,000 articles. Here, I can see that my query has been translated somehow into a human-readable query. In the center part, we see the result search, and on the left side, some filters, a series of filters. As I've been mentioned before, there is a problem of OCR mistakes, and we have implemented ways to suggest to the user words which are similar, coming from semantic similarity or from common OCR mistakes. So here I will look, thanks to word embeddings, to words which are similar to my request. So I see Ehrmann, but I also see Ehrmann with a N transformed to M. So I will add it to my search. I see also the German name for the city, as well as another typos where the H have been inverted. So I can apply this to the search, which gets now to 6,800 articles. So this is a search, what we call the search bin, where one can compose quite complex search elements. Here we have the frequency of the timeline of the search hit given by this query, and then a long series of filters based on metadata as well as on semantic enrichments. I go directly on the topic filters, where I'm interested in trying to perhaps expand or narrow down my search. And I can see here that the topics which have been identified in this collection of results relates to either the battle or to sports, such as football, because of the football club of the city. So I would like to get rid of the articles which are related to sport. So I will select the articles, the topics which are about match, jeu, equip, and tournament, something like this. I apply this to my search, but instead of getting articles related to these topics, I will specify that I want the articles which are not related to these topics, and therefore I will have a result set which now come down to 5,000 articles, and which is somehow guaranteed without sport article. Now let's have a look at the article viewer. We can select one, for example, this one. We see first the page view with annotation, main annotation, which are displayed on the margin, and we can switch to the transcript view to have a zoom on the article with the OCR and the facsimile. On top of it, we see a summary of the annotations extracted from this very article. For example, the person Marika Hook has been identified, and we see here is information related to this person, which has been linked towards a Wikidata ID. If I scroll down, I can see, I can get suggestions for similar articles of this one. And I also see here on the right-hand side, a little sign showing me that this article has been identified as being part of a text reuse cluster, meaning have been reused by in other articles. If I don't know what is text reuse, there is an info button giving some information about this processing. Let's quickly jump to the newspaper page, which offers a view of the corpus behind impresso interface as well. So this displays some information about the newspapers, and we try to keep count of the missing data. So there is information about each title and the missing data for each title. One can explore an overview of the annotation containing one title, etc. There is different ways to explore the corpus based on topics, based on the inspect and compare tool, which is very powerful in order to compare a query or collection, a personal collection, where I will have added my own article. I just want to briefly illustrate the text reuse search, where I will enter the same Ehrmann keyword. And I can see that it has been mentioned in some cluster, 900 exactly. And if I click on one cluster, I can see the distribution of the annotations in this cluster as well as the passages. And here it's all about the weather conditions which have conditioned this battle. I can refine the cluster my look into this text reuse by playing with some parameters. Going back to the search, which is a sticky search, my search never disappears. I can always modify it. I have my human readable summary. I just want to briefly show that you can search through the visual image search. It takes a while to load. And you can also have n-gram profile to see the frequency of someone. You can scroll and browse your own collection, etc. So this was a very, very brief tour of the interface. Thank you. For more information, I invite you to visit the impresso website as well as the impresso YouTube channel. Obviously, you are more than welcome to try the impresso application and to give feedback. And we publish the data on the Zenodo platform and our code in open access on GitHub. Thanks a lot for your information, and I'm happy to answer any question you may have.
Thank you, Maud. A very impressive project indeed. I have a little bit technical question. OCR is a very, very challenging topic, especially with newspaper text printed on not very good quality paper and in large volumes, so the print quality is also not so good. Did you estimate what percentage of material you had lost before you tried to improve the OCR? So is there a measure of how much your machine learning applications helped to improve the quality of the OCR?
Yes, thank you for the invitation and for this question. Can you hear me well?
Kas ta ei kuulnud või mis need oli? Sorry, shall I repeat the question? Yeah, the question was, did you measure the impact of your machine learning tools to improve the OCR of texts? You mentioned messy data before you applied your OCR, and then you were able to process the text afterwards. Was there a percentage by which your project managed to improve the OCR quality?
Yes, we have been measuring the improvement of the performance on the Neue Deutsche Zeitung, so only one newspaper which has black letter, and where this improvement have been really pushed forward because the quality was really bad. I do not have the exact numbers in mind, but it's by more a double-digit increase in points. And what is more, it is evenly distributed over the time, meaning it managed to improve the quality for the 200 years which are considered, and not only for the latest part of the corpus. However, I just want to specify that we did not improve the OCR for the entire corpus because our corpus comes from different institutions and the quality was very heterogeneous, and sometimes we didn't really need it. And since it was not the primary focus of the project, which was a text mining per se, sometimes we could still work without correcting.
The system architecture that you're using, did you actually download the images and metadata into your system and then processed everything in your project? Or is the architecture such that your tools are going and accessing content in the repositories of participating libraries?
That's a very interesting question, very relevant, because obviously developing such an infrastructure is heavy in terms of servers and in terms of storage. So it's, again, a quite nuanced picture, I can say, because every institution, every memory institution do not have yet, I would say, perhaps do not have yet developed capacity of APIs to access remotely either the image or either the text. With the IIIF API, it is now more and more frequent to be able to deliver image remotely. Actually, one institution do this, and this is our favorite option, since Then in the interface, we go directly on the IIIF endpoint of the institution, and we do not have to hold terabytes of images on our server, which is quite a thing. And but nevertheless, only one institution out of 7 could provide this at the time of the project. So we had to exchange data, and so that's one point, that all institutions do not yet provide such facilities. And the other point is that sometimes, for computational reasons, we need to have a working copy on the server in order to compute things. So even though there will be a remote access to compute, for example, image similarity, it's best to have image on locally, but we can afford to have a working version, meaning less good resolution or things. But in the future, we are really looking for a better infrastructure, maintainability somehow, and lighter, such as people like our institution or project will focus only on the processing, while institutions really focus on preserving and giving their data a working copy from remote. That will be ideal. I think we are going towards such a setting, but it's not yet there.
Mm-hmm. Okay, it would also probably make it easier for new institutions to join your service, or come with their newspaper collections and make them available for analysis through your interface. All right, thank you very much for your presentation today.